First thing we're going to talk about, of course, is going to be an introduction to the Apex programming language and what are some of the general things that make it different from other programming languages, being a cloud-based programming language. So let's talk about the tools, things like governors, and different considerations in introducing it. So introduction to Apex. Well, first of all, Apex is a fully object-oriented programming language. So the things that you're used to having available to you, things like encapsulation, inheritance, polymorphism, defining interfaces, all that kind of stuff, and just in general, you know, the concept of defining a class, that class having methods and variables which define its behavior and its properties. All of that stuff is available to you with Apex. It is a on-demand or a cloud computing language. In the case of Java, you can have a local Java runtime environment and you can execute your code on your own system, or for that matter these days, if you're using an Android device, you're running Java on your cell phone. Well, that option does not exist for Apex. Apex only runs on Salesforce servers up there in the cloud, okay? So it is truly an on-demand language that only runs within that context. It is very similar to Java or C# with respect to the syntax. So one of the things I tell folks is that, you know, it's basically, when you compare it to Java or C#, it's 80% the same. But it's the 20% that really gets you in trouble. So the differences are very significant, and that's what we're going to be focusing on this week. So it runs on our multi-tenant environment. It plugs into a lot of our platform features. So like I said, whether you're creating a custom solution, a custom application, or whether you're extending the CRM applications, it gives you the ability to interact with those applications. I already talked about the fact that it runs in the cloud. One of the nice things about Apex is that it has an implicit connection to the database. So we'll be taking a look at code, and you'll notice that we're not going to be worrying about things like, you know, connections to the database. It implicitly has that connection. In addition, it also has the ability to, or it will do this for you, where when you go in to the setup menu and you go to create objects and you define a new Salesforce object, it's going to automatically declare a data type for that object. So for instance, when we created the position object, because it was custom, it was called position_C. In Apex, there is a class that's now available to us, position_C, which is of type SObject, which is now available. In addition, anytime we create custom fields, those will now be member variables within that class. So it has a nice binding, a nice connection up to, you know, between the application server and the database layer, taking care of creating those data types for you so that you don't have to worry about it. Not only does it have a built-in framework for testing and deployment, it actually requires testing. So we'll be working with that later on within our labs. The other thing to keep in mind with respect to Apex is that it is not intended to be a general purpose programming language. So I brought up the example of Java. You know, Java's intent was to be portable across every single device, and therefore folks can create, you know, web-based applications in Java that are running on application servers, or for that matter, there's the, you know, the cell phone version. You could create a Java application, you know, using something like the Android operating system to run your Java applications. Apex is not intended to be that general purpose programming language. It is a business back-end programming language that natively plugs into all those different features which are available on our platform. But you know, it is built for a specific purpose. Okay. In addition, it's also governed because it does run on a multi-tenant system and our customers pay that flat subscription fee to use our system. We have something called governors which enforce efficiency, and we'll be taking a look at those later on. All right. Some of the commonalities, so I talked about the object-oriented capabilities. Both have classes, all those object-oriented concepts. They have very similar syntax. Both are compiled, both are strongly typed. Both have transactional capabilities. I'll be talking about those with respect to Apex. Some of the key differences, Apex runs on that multi-tenant environment, and therefore we have the governors. And I'll be talking about how we can write our code to be more efficient so that we don't run into those. It's also case insensitive. So just understand, if you attempt to declare two variables, one uppercase and one lowercase, Apex treats them as the same thing, so it's very different in that regard. As I mentioned before, it only runs on the cloud. So it's compiled on the cloud and it runs on the cloud. When you're using the Force.com ID, which we'll be using during this class, what's going to happen is if you're going to compile some code, it does not compile locally. There is no version of Java-C that you might be used to if you're developing Java code that's going to compile that. What happens is that we take the definition of that class, we copy it up to the Salesforce servers, and then we compile that code on the servers. Okay? So both the compilation and the execution environment. Talked about here, it's not a general purpose programming language. So there's a number of things which we do not provide, things like graphics libraries. We don't have those on Apex. There's also a number of things where we don't provide you with lower level access to the subsystem. And so the reason is due to security and stability, which are the two most important things at Salesforce. We provide a layer of abstraction to do common functions, but we don't have, for instance, lower level access to the file system or network sockets or threads, that kind of stuff. Okay? We provide you with the functionality to use those things, but we do not give you the ability to say thread T equals new thread, for instance. Okay? It requires testing, and so we'll talk about that when we cross that bridge. The two main structures that you're going to be working with when you're developing your Apex are Apex classes, which are just that. They're templates for objects. And then there's triggers. So just so you know, trigger is its own thing. A trigger is not a class that implements the trigger interface or something like that. Trigger is a keyword in Apex. And what you do is you declare a trigger and you associate it with an object. And so anytime, for example, when a person is inserting or updating records, that would then execute your trigger. A trigger, think of it as merely being a procedure. So in other words, a trigger is when this event happens, execute this procedure. One of the things you could do is you could call a method in a class. So maybe in your trigger you would instantiate an object if that's what you wanted to do, or if you just have a utility method, you could define a static method within a class and then call that method from your trigger. Okay? These are the two main structures that you'll see. There's also a third one that exists, which are interfaces. And so you can create a top-level interface and then in your classes go about implementing that interface. Okay? All right, when we think about all the different ways that we can invoke Apex, there's a number of different options which are available to us. Now, first of all, I want to explain this diagram. You'll notice that there's a cloud and then there's sky below the cloud, okay? And the way you can think about this is that the cloud, the white area represents the Salesforce system, and then the blue sky represents things that are external to Salesforce, okay? All right, so let's start on the left-hand side and talk about all the different ways that we can invoke our Apex code, and there's a large number of them. So first of all, you can create a trigger and associate that trigger with an object and define the different events that you want to detect, and then we can execute that trigger upon those events occurring. Now, it doesn't matter whether or not your end users are using the default Salesforce user interface. So they might be doing what we were doing previously with a position record, creating it and saving it. Or for that matter, they might be using an API-based tool. So something like Data Loader, for instance. Somebody might be loading in records into Salesforce. That is a DML operation. It then would execute our triggers. For that matter, we might write some Apex, and the Apex might be inserting or updating or deleting records, and once again, that would conceivably fire off our triggers if they're set to execute. Okay? So that's the number one way that number one entry point into Apex code is via Apex triggers. You can also create Visualforce pages, and Visualforce pages can be bound to either custom controllers or controller extensions. We'll actually be working with those later on this week. But what happens in this case is that you can call a method or a number of different methods in your Apex controllers. Your Apex controllers are just Apex classes, and so we can execute code that way. There's also something called email services, and so if we want, we can set up an email service so that when someone sends an email to a predefined email address, we can execute some code. We can implement an interface in order to execute that code. We can use something called anonymous blocks. Execute anonymous is the ability to run a segment of code, a subset of code, a few lines of code, or a lot of lines of code. Think of it as, if you were in the Java environment, you might want to create a little command line utility. And so what you'd do is you'd implement, public static void main, and that way you have the entry point into your Java code. You could execute it as a command line by calling the Java runtime environment and then your class. Well, how would we do that within Apex if we don't have access to a JVM or anything like that? Well, what we have is something called anonymous blocks, which we'll be using throughout the course of this class. You can just define some inline code, execute 5 lines of code, and then it's just going to execute it and compile it dynamically up on the server. Execute those 5 lines. Maybe you instantiate an instance of a record, you populate field data, and then you insert that record into the database. Think of it almost like the body of a method. You can do that using an anonymous block. So one of the most misleading things about anonymous blocks is that people, they see the anonymous part and they think, oh, am I not logged in? Think of it as anonymous is not applying to the logging in. You always must log into Salesforce to do anything. The anonymous, think of it as an anonymous class. So in something like Java, you can say I have an interface and I want to implement a method in that. I don't want to necessarily declare a class. I can declare it anonymously. I think that's the meaning of the word anonymous there. But in order to execute an anonymous block, you must first, whether you're doing it via web service call, or we can also execute anonymous blocks via the Force.com ID or the developer console, you always must enter in credentials and authenticate yourself before you can do that. Okay. You can do a web service call into Salesforce. The way that we implement custom web services on the Salesforce platform is via Apex. You can create custom SOAP-based web services, or you can create custom RESTful web services. All we do is we define an Apex class, and then we define our web services, and then our external client can call those methods which are published as web services. That's another entry point into our code. And then finally, there's the Apex scheduler. And so the Apex scheduler, you can set up something like a weekly schedule. So let's say every Saturday I want to execute some code, and maybe I'm going to go out and search for duplicates, or I'm going to do some sort of cleanup of my data on a weekly basis. So the scheduler is just that. It's a cron job where you can identify some code to execute on that schedule. So when we reach that point, let's execute the code and do whatever it is that we want on that schedule basis. Okay. Let's take a look at a classic example of implementing Apex. And so here we have a trigger which is going to do some deduplication. So let's say that a user is filling out a lead record. So they're using the Salesforce user interface. They click on that Save button, which is going to write that record to the database. In our case, we've set up an Apex trigger associated with that event. And so we're going to execute that logic within that Apex trigger. What it's going to do is it's going to do probably something like a database query. It's going to take a look at information within that record, do a database query for records in the database, and then if it finds a duplicate, maybe it prevents the record from being written to the database, so much like a validation rule. Or perhaps it is going to not find any duplicates and therefore allow the write operation to occur. Okay? So a classic way that we would implement an Apex trigger in order to meet some business requirements. Now, here's some code that would be behind that. So here's our trigger. And so don't worry about understanding the algorithm here. Don't worry about understanding what this code is doing. At this point, I just want to point out some of the syntax and some of the things that you'll see in Apex. So first of all, as I mentioned before, trigger is its own keyword. And so you'll notice that on line 1, it's the definition of or the declaration of our trigger is right there on line 1. This is a trigger called lead duplicate preventer, is associated with the lead object. And there's a couple of events that this is going to detect that it's going to execute its code associated with. Within Apex, we have collections. So we have sets, lists, and maps. And so those are available for us to work with. There's a for loop. So we have for loops, while loops, do loops, so a number of looping constructs. Notice we have some complex logic here. We have parentheses in order to establish a hierarchy and precedence. We have or, we have and, so we can evaluate our data. Here we have our if-else statement. So if something is true, let's do this. Else, let's do something else. Down here on line 16, we have a SOQL query. SOQL stands for the Salesforce Object Query Language. This is our version of SQL. So we use this language. It is slightly different. Once again, it is 80% the same, but it is different from SQL in a number of different ways. We'll spend some time talking about this later on. But this is our query language that we use to query our multi-tenant database. Notice that if I want to fetch data from Salesforce, like we're doing here, the Salesforce database, I just write the query and execute it inline. You don't need to create a database connection. There's already the data types and the connection to the database to perform that query. Here we have a variable declaration. Apex is strongly typed. It also supports the ability to do things where you have a parent class as the type and then the underlying object as a subclass. So there's that kind of functionality. And then here we have a data operation. We can prevent records from being written to the database. We can write records to the database using DML, which we'll take a look at later. So we have a lot of different capabilities available to us. All right. Apex, I mentioned that it's strongly typed. It also goes off of your metadata definition. So I talked about how if you create a custom object or custom fields, what we do is we generate data types associated with those that you can now use within your code. Apex is metadata aware, so it knows, for instance, if you create a number field versus a text field, that a string versus a numeric value. One of the things we can do is we can associate a version with our code, and that way we're using that version of the compiler, and it gives us the ability to maintain that backwards compatibility when we're developing on the platform. The main place that you're going to go for Apex documentation is the Developer's Guide, so the Apex Developer's Guide. You can access the help through Help and Training, or you can go out to developer.force.com. You can access the HTML documentation or download the PDFs. Okay. And then there's a number of other things. available on developer.force.com, including the cookbooks. And the cookbooks are nice because it has recipes, which are samples of what people have done with respect to code.